All right, let's tackle a term that you hear absolutely everywhere: big data. I know, it sounds kind of intimidating, doesn't it? Like it's something only those giant tech companies have to deal with. But trust me, by the end of this, you'll realize it's a concept you can totally grasp just by thinking about your local corner shop. So let's start by, opening up that shop's little diary.
This one question right here, it's the key to unlocking this whole topic. Seriously, how did we get from a simple handwritten ledger to the absolute digital flood of information that powers companies like Amazon? Let's dive in and break it down.
So, on the left, you've got data you can literally hold in your hand, a local shopkeeper's diary tracking daily sales. It's simple, it's manageable, but let's be honest, it's slow. Now look to the right. That's not just data, that's data in constant motion. A behemoth like Amazon is processing thousands of clicks, purchases, and reviews every single second. There's no way you can track that in a diary. And that overwhelming, non-stop flood of information, well, that's big data in a nutshell.
Okay, so let's actually trace that journey. In part 1, we're going to see exactly how that simple diary swells into a full-blown data tsunami, and we'll pick up the lingo we need to talk about it.
So here's the textbook definition for you. Big data basically describes any data set that is just too massive, too fast, or way too complex for the old-school databases to handle. In other words, the digital version of our shopkeeper's diary just isn't cut out for the job anymore. It can't keep up. Now here's what's really cool. We characterize big data by a lot more than just its size. We use what's known as the 5 V's. First up, volume. We're talking about a mind-boggling scale here, terabytes and petabytes of the stuff. Then you've got velocity, the insane speed at which this data is being created, a lot of it in real time. Third is variety, which means it's not just neat rows and columns, it's everything from structured text to photos, videos, and even sensor data. Fourth is veracity, which asks a really crucial question. Is this data any good? Is it trustworthy? And finally, the V that matters most, value. What can we actually learn from all this information? Like when Netflix analyzes all our viewing habits to figure out what hit show to make next, that's turning data into real value. This slide just perfectly nails the huge shift in thinking that was needed. In the old days, if you needed more power, you scaled vertically. You just bought one bigger, badder, more expensive computer. But big data systems, they scale horizontally. So instead of one giant machine, they use a whole network of smaller, everyday computers all working together. Need more power? You don't buy a bigger box, you just add another computer to the network. It's a completely different, way more flexible approach.
And how do we actually process all this data? Well, there are 2 main approaches. You've got batch processing, which is kind of like our shopkeeper who tallies up all the books at the end of the day. It all happens in one big go. Then there's real-time processing. Think about when you swipe your credit card and instantly get a fraud alert. The system is analyzing that transaction the very second it happens.
Okay, so we've got the 5 V's down. We get the new architecture, but how on earth do you actually manage this massive, fast, and super messy flood of information? In part 2, let's get into the real challenges of trying to tame this data beast. To really get your head around the scale of this challenge, I love this analogy. Imagine you're in charge of organizing the Kumbh Mela, one of the largest human gatherings on the planet. And all of a sudden, millions of people start showing up at incredible speed from all directions. That logistical nightmare, that is a perfect metaphor for the core challenge of big data.
So let's break that logistical nightmare down into the main challenges. First, you have scalability. What happens if twice as many people show up as you expected? You need to be able to add more tents, or in our world, servers, instantly. Then there's fault tolerance. What if one of your main power generators goes out? You can't just let the whole festival plunge into darkness. The system has to have backups. And finally, cost optimization. You have to manage this whole shebang without the budget just going completely off the rails.
Let's just zoom in on fault tolerant for a second, because it is so important. In a system that has thousands of computers, some of them are going to fail. It's not a question of if, it's a guarantee of when. So big data systems are actually designed with this in mind. They make copies of your data and spread them out across a bunch of different machines. So if one computer dies, the system doesn't even blink. It just keeps right on working.
So how do you solve these absolutely monumental challenges? Well, the answer is in building a very special kind of architecture. And honestly, the best way to picture it is as a massive 5-star kitchen.
Let's take a walk through our 5-star data kitchen, shall we? It all starts with ingestion. This is where the raw ingredients, all our data, arrive from all sorts of different suppliers. Next up is storage. We take everything and put it into this huge cold storage unit called a data lake. It's basically a place to keep all the data in its raw, unfiltered state. Then comes the processing. This is where our chefs get to work. They clean, chop, and prepare the ingredients, turning that raw data into something useful. After that, analytics. This is when the customers get to see the menu and taste the food, usually through things like business intelligence dashboards. And finally, we have ML integration, where we use all that customer feedback to smartly predict what tomorrow's most popular dishes are going to be.
Phew, we have covered a lot of ground, from tiny corner shops all the way to 5-star data kitchens. So let's wrap this all up with the key things you really need to remember. If you remember just one thing from all this, please make it this. Big data is not just about being big. It represents a complete evolution in thinking. It's a whole new philosophy for handling information that our old traditional methods simply cannot cope with anymore. And hey, to help you lock all this in, here's a quick little memory hack. For that 5-step architecture pipeline, just remember the acronym ISPAM: ingestion, storage, processing, analytics, and ML. And for those 3 huge challenges, just think SFC: scalability, fault tolerance, and cost. Simple, right? So we'll end on this thought. You always hear that phrase, data is the new oil. And for a long, long time, we had all this crude data, but we really didn't know how to refine it. Now, with the kind of architectures we've just talked about, we finally have the refineries. So the real question now is, what are we going to build?